Hi, I'm Hagen, and this is my finished project 2 for QM 238 Data Analytics 2. So the first thing I did was I imported all my basic functions such as Panda, Seaborn, Matplotlib, .pyplot, SPLT. I then imported more functions which were needed for later classification, such as sklearn, skmulticlass, sklearn.metrics. All these were needed for my classification. I then read the data that was given to us. So we were given the Purple Team Project 2.csv file. I then um, displayed the data frame. So from this data frame, we are supposed to classify the data in order to target the race with the race attribute as our target. So the next thing I did was I used the shape function to see the dimensions of the data frame. The data frame was 32,561 rows by 15 columns. I then used the .describe function to provide a statistical summary of all the data. I then used the .dtypes or .datatypes function to see the type of data inside each attribute. The integers, the int64 means an integer value, and the object means a categorical value. And then listed out and defined all of the attributes. For example, the hashtag is equivalent to the age of the person. The FNLWGT was the final weight of the column. I then ran the .isNA function and the .sum function to see how many missing values there were in the dataset, and as you can see, I got 0. I then wanted to see how many duplicate rows there were in the dataset. I got that there were only 24 duplicate data rows, so not bad. However, I did go ahead and drop those duplicate rows as you see here by using the df.dropduplicates function. The next thing I did was create a box plot to see any outliers. As you can see, the only attribute which had major outliers were the final weight category, and those were needed because things were weighted differently depending on how many people fell in each group. I then generated a correlation matrix, and I found that there was not much correlation between the numeric values. This led me to believe that there would not be a high accuracy score for the race clustering. I then worked to turn some of my categorical attributes into binary. Let me fix that. Alright. Then I created a heat map, used sp.heatmap. So now I'm transitioning into the part 2 section. So I determined that the problem would be an example of a multi-class classification problem since there are multiple races or multiple classes involved in the clustering. I then decided that I'll be using one versus rest classification because I want to cluster the race based on the rest of the set to see what makes it different. I then determined that the data did not need any standardization because each attribute's data is already standardized, meaning it is of the same type. I then began to turn the rest of my categorical attributes into binary attributes like I did before. I did the education attribute here, the marital status attribute here, occupation, relationship, sex, native country. The only thing I left was the race attribute, just so it would be easier for me to see. I did the salary as well. So the next thing I did was to create a data sample with replacement. So the purpose of sampling, so I chose a sample replacement so data can be selected more than once. I used n, or the sample size equals $1,000. As you can see, here's my code. I did the df.sample function to do all this. I then set what attributes I would be using, and then I set my target. Like I said before, my target was the race category, so I set that right here. The next thing I did was begin everything I need for clustering. I set the test size as 0.1. I then split the data set into X-train, X-test, Y-train, and Y-test. Excuse me. So the next thing I did was I made shortcuts for the scaling functions I needed, or programs, excuse me. Then I reset the index for each thing. X test, Y test, as you can see right here. And then